So there's two types of problems we're going to look at. One type of problem is when I have two ratios equal to each other or a set of proportions. That's what problems the first six look like. The first six are all proportions. The second set, when we get to problem number 7, I cannot do the same technique that I'm going to do in 1 through 6. I can't just cross multiply. Okay, so so I'm going to show you a method that works for those problems. All right, so again, at some stage you'll probably work ahead of me, which is fine. Just be careful. We learned back in the 7th grade when we had, and we'll break it down smaller. If we had 3 over 10 is equal to x over 14, we learned that if I have two ratios or a set of proportions equal to each other, I can cross multiply. Do 3 times 14 is equal to 10 times x. 3 times 14 would be 42. And then I can divide off the 10. And x is equal to, divide those top and bottom by 2, and I get 21 over 5. And there was my answer. That's what we learned in 7th grade about proportions. Their cross products are equal to each other. Some of you just did it on the calculator. You actually physically got the calculator out and said 3 times 14 divided by 10. And you didn't show the steps to it. Okay, you remember doing that? Okay. And again, back then we could do that because it was super simple. It was easy to kind of do. Now when we start putting letters in both parts, some of the things are binomials and all this other stuff, it gets a little bit more challenging. That's why we got to track our work and so forth. So we got to be careful. So with that in mind, same process. I'm going to cross multiply. 7 times x equals 4 times x minus 6. And again, you know me, I'm going to show the long way so we don't forget something. 7 times x is 7x. I got to distribute the 4. That gives me 4x minus 24. And then now I solve for x. So now I'm just going to subtract the 4x over. I get 3x equals negative 8. And then I divide both sides by, negative 24. Sorry, my brain was working ahead doing 24 divided by 3, which is what? Negative 8. So I was already getting to the answer. Woohoo. There we go. And then I told you earlier, we have to do what with this topic? Yeah, we got to check because we could have extraneous solutions here. We had that topic up earlier. Yes?
I don't have it.
I thought I just handed you one. Oh, I handed you a +1. Sorry, wrong stack. Yeah. All right. So we should go back and say, is 7 over negative 8 minus 6, are you equal to 4 over negative 8? Well, that's 7 over negative 14, which is negative 1/2. And on the other side, it's negative 1/2. So those two things balance. Now notice I brought the negative out to the front or up to the top. Some of you are still leaving the negative in the bottom, and I've told you no, 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 no. Okay? All right, let's do number 2. Number 2, we cross multiply. 3 times 2a plus 1 equals 7 times a minus 8. Now we distribute both sides. 3 times 2a would be 6a plus 3. On the next side, I distribute the 7. I get 7a minus 56. I'm going to add the 56 to the left and subtract the 6a because I saw in advance I wouldn't have to do any division. And I get a is equal to 59. And again, I'm supposed to check. All right? I got to check to make sure that it works out. So 3 over 59 minus 8, is that equal to 7? 7 over 2 times 59 plus 1. All right, that's ugly, but let's see, that'd be 3 over 51. That becomes 1/17. On the other side, I have 7 over, that's 118 plus 1, which is 119. And 7 does go into 119 17 times. So those do balance. Okay. So that lets me know that 59 is the one solution that balances those proportions. Now, sometimes we have one answer choice. Sometimes we have more than one answer choice. Is it okay for me to zoom in on number 3? Or does anybody need number 2 anymore? All right, number 3. As we cross multiply on number 3, we get r squared equals 4 times r minus 1. So this becomes r squared equals 4r minus 4. And then I'm saying, all right, I got to get everything over to one side, factor, and find my solutions. So I'm going to subtract the 4r and add the 4 to the other side. So this is r squared minus 4r plus 4 equals 0. That's an r minus 2 times an r minus 2. And really, I only have to solve one of them because they're identical. So I can just solve one of them and find out that r is equal to 2. And then I'm supposed to, again, check it. So 2 over 2 minus 1, are you equal to 4 over 2? Well, that'd be 2 over 1, which is 2. That's the left side. Right side is 4 divided by 2, which is 2. So, hey, yoo-hoo, there's my one solution. Okay? Again, these are the nice, easy ones. Again, if you work ahead of me, if you want to work ahead of me. Next one takes a little bit longer because I see I have 2 binomials, m plus 3 times m minus 2 equal to 3 times 8. Well, we know what 3 times 8 is. It's 24. So I need a FOIL. M squared minus 2m plus 3m minus 6 equals 24. I'm going to bring the 24 over to the 6 as I combine the middle stuff just to try to speed things up. M squared plus m minus 30 equals 0. That factors into an m plus 6 times m minus 5. So I get m is equal to negative 6 and m is equal to positive 5 for my two answers using the ZPP, the zero product property, which we talked about 2.5 months ago. Okay. Now I need to check both. Negative 6 plus 3 over 3. Are you equal to 8 over negative 6 minus 2? All right, that's negative 3 over 3, which is negative 1. On the other side is negative 8 over 8, which is a negative 1. So we know negative 6 works. So now I got to test 5. Is 5 plus 3 over 3, are you equal to 8 over 5 minus 2? Well, that gives me 8 over 3 on the left, and on the right is 8 over 3. So that's a solution. So that one has 2 solutions. Again, I know it's a pain to have to check to see if the things are solutions or are they extraneous solutions. I know, but again, I'd hate to miss a problem because I didn't take the time to check. Why don't you do the next one ahead of me? I'm going to take attendance here real quick. You guys do that one, and then we'll see if you got the right answer or answers. Hey, Paige, didn't Harper say she was going to come back?
No.
No? She didn't get the stuff. Willie did. Willie made sure he got all the papers and stuff. She just didn't want to wait around for me to give it to her. That's what it was. All right. Oh, sweet. I put that over. Ooh, that's a big file. Sorry, I was one of my seniors. They lost their iPads, and then their Microsoft accounts get deactivated. So she wanted her notes from calculus to have for college. So it took about 50 minutes to create the PDF of the notes because it was such a large file. All right, let's see if I can catch up relatively swiftly. All right, so I'll show all my steps. 2x minus 3 times x plus 4 are equal to 6. And then we have 2x squared plus 8x minus 3x is a plus 5x minus 12. Bring the 6 across. 2x squared plus 5x minus 18 equals 0. That factors into an x plus and x minus. Factors of, I like that. I like the 9 here, the 2 with the 9, x and, oops, sorry. Don't need an x, I already have it. And then a 2 there. 9 times 2 is 18. 2 times 2 is 4. Subtracted from 9 is 5 in the middle. So that means x equals 9 halves. X equals 2. And then we're supposed to check it. And again, this is where it gets challenging. I know some of you may want, and if I'm going to leave it the way it is, but, if you want to turn it into 4.5 and put 4.5 in there, you can. It's just about, the checking, just takes a while. So if I put the 2 in there, I get 4 minus 3 over 2, which is 1/2. If I put that, I'd be 3 over 6, which is 1/2. So 2 works. The 9 halves gets ugly. 2 times 9 halves minus 3 over 2 equals 3 over 9 halves plus 4. So the 2's cancel, and I get 9 minus 3 is 6 over 2. On the here, 4 is really 8 over 2. So that would give me 3 over 17 halves, right? I'm double checking to make sure I didn't write anything down wrong. All right, that would flip over. That gives me 6 halves equal to 6/17. Don't think that works in my book. Just double check and make sure I didn't make a goofy mistake. 9 halves, 8 halves, 17 halves, yeah. 2 goes up, it's a 6 over 17 on the other side. 2's cancel, 9 minus 3 is 6. Yes, so no. So that's extraneous. Okay? So, and again, you could use decimals. All right, now this is where it gets harder. It gets harder from the standpoint of we can't straight cross multiply. We can only go straight to cross multiplying when we have a fraction equals a fraction or a fraction equals a whole number. Because we can put the whole number over 1 and then it's a fraction and a fraction, okay? So this one, we have options. You could get a common denominator on the left side, practice yesterday's lesson, and combine those into one fraction on the left, then you could cross multiply if you want. I like, in the way the directions start giving you an option is, let's multiply through by the least common multiple and clear the fractions, get rid of the fractions, Okay, I know he's shaking his head no, but he means, yes. Okay, so so that's what I'm going to do. Least common multiple on this one is 6n. And so what I'm going to do is I'm going to multiply each fraction by a 6n. If I look at my denominators, does 3 go into 6? Yes. So the least number multiple is 6. And then we have the random letter n, so I have to use 6n as my combined least common multiple. If you want to use 18n, more power to you. You're just going to have to reduce more. Okay? If you want to take all those bottoms and multiply them together, more power to you. The challenge is, as some of you saw on some of the stuff, you made it so big it was hard to figure out how to reduce. So, now here, this is where it gets, does everybody have that written down that wants to do it this way? Okay? Now, this is where it kind of stinks with technology for pointing, because if I point with my pen, you can't see me point with my pen, okay? So, we tackle each fraction separate. The 3 goes into 6 how many times? 2. So, the 3 cancels the 6 and makes it a 2n. So, this is 2n times 4 is now that first term. No more fraction. Minus the n in that denominator cancels the n that we're multiplying by. And I'm just left with the 6 times the top, the 7. And then on the other side of the equal signs, the 6 in the bottom cancels the 6 we're multiplying by. And I'm just left with n times 1. Now there's no fractions. I can simplify 8n minus 42 equals n. I'm going to bring the 8n across. I get negative 42 equals negative 8n. And n is equal to 7. And then what am I supposed to do? Check. So,
you go through that one more time.
Yeah. So, you okay with the least common multiple? Put it on each one.
Sure.
Okay. So, we go with each denominator. That divides into what we're multiplying by. Well, 3 goes into 6 2 times. What's left gets multiplied to the numerator. Copy down the minus sign. The n cancels the n that we're multiplying by, and then the 6 gets multiplied to the numerator. And then along the other side, the 2 6's cancel. And I just get n times 1.
Is that not a minus 7? Oh, wait, no, I didn't put that one.
You only use the minus sign once, yes.
Would it not be negative 42 equals
Sorry, yeah, sorry. I was, sorry. My bad. It should be a negative 7 and there should be a negative 6. My apologies. Negative 7 and that would be n is equal to 6. My fault. Okay. So, we'll go back to planing up shop back here. All right. Now, again, if you want to combine the two fractions on the one side and then cross multiply, you can. If I put a 6 in there, this is where we would have found out that I did something wrong, because when we put the 8 in there, we realized it didn't work, and then I would have double checked and stuff. So 4 over 3 minus 7 over 6, are you equal to 1/6? Well, 4 over 3 is really 8 over 6 if I multiply top and bottom by 2. 8 minus 7 is 1, so yes, that worked. Okay, yes.
How'd you get 6
How- How'd I get what?
6
For the least common multiple? Between the numbers, the first multiple that 3 and 6 have in common is 6. So that's the least common multiple for number-wise. And then since the n was the only n in the bottom, it had to be tagged on. Okay? All right, now, as I look at number 8, there's two types of denominators. There's a k and there's a 2. So the least common multiple is 2k. So that's what I'm going to multiply everybody by. Each fraction gets multiplied by that. And then now we take each fraction one at a time. We look at their denominator, and we say, all right, the k in the first fraction cancels the k we're dividing or multiplying by, and I'm left with 2 times 3. In that spot of the problem. Minus sign. The 2 in the denominator cancels the 2 of the 2k, and I'm left with k times 1. On the other side of the equal sign, the k in the bottom cancels the k we're multiplying by, and I'm left with 2 times 12. Yes?
Could you simplify that to 1 times 6?
Can I do what?
Never mind.
Okay. Remember, I'm trying to go the slowest I can without losing, is what I'm trying to do without losing you. Okay? 6 minus k equals 12 is equal to 24. And then we're going to subtract the 6. I get negative k equals 18. Therefore, k is equal to negative 18. And again, I'm supposed to double check it. Is 3 over negative 18 minus 1/2. Are you equal to 12 over negative 18? Well, that's negative 1/6 minus 3/6. I'm going to go ahead and get common denominators. Are you equal to, I can divide that top and bottom by 3, negative 4/6. I didn't go by 6 because I need 6's in the bottom. And then I get negative 4 over 6 equals negative 4 over 6. So I'm like, woohoo, that worked. Any questions on that one? There's always ways to speed it up. There's always ways to fit it, to simplify faster. Again, if you want to use that getting common denominators on the left side, like we learned yesterday, combine the two fractions, then cross multiply, you can do that too. Okay, you have your freedom. The challenge is, as we get more robust type of denominators coming up with a bunch of letters and binomials and trinomials, doing that may not be that advantageous. Okay? With that in mind. All right. On this one, I am going to factor the bottom of the bottom right. P over P minus 2 plus 2. Are you equal to 8 over P minus 2, P plus 2? So, again, sorry for the sloppy handwriting. So, when I look at this, the P minus 2 times P plus 2, that's the least common multiple. Because the 2 is just over 1, so I don't have to worry about its denominator being involved in the least common multiple. The other denominator is one of those two things. So, I'm going to multiply everybody by P minus 2 times P plus 2. That's what I'm going to set it up as. So, P minus 2 times P plus 2 times the P over P minus 2 plus P minus 2 times P plus 2 times the 2 over 1 equals, and then P minus 2 times P plus 2 times 8 over the two things and then now I'm ready to reduce stuff. Okay? Man, this is the long part. All right, so the P minus 2 in the bottom, in the first fraction, cancels the P minus 2, and I'm left with the P plus 2 times P for the first term. Then I have a plus sign. Well, the denominator is 1, so really I don't have anything to cancel, so I'm left with multiplying 2 times P minus 2 times P plus 2. I got to multiply that out. And on the other side of the problem, both parts of that denominator go away, and I'm just left with 8, the numerator. Now I need to kind of multiply carefully with the stuff on the left, then combine like terms, bring the 8 over eventually, and then start solving for the p. All right, that's how it factors. 3p plus 8 and p minus 2. Three times negative 2 is negative 6. 6 negative 6 subtracted from 8 is positive 2. That's how I got that in the middle. So I got my two answers. P is equal to 2. P is equal to negative 8/3. And I'm supposed to check both of those. Again, this does take forever to check it. Okay? Now, right off the bat, I'm going to check the whole number. I'm going to check the whole number too. What happens when I put a 2 in that first fraction? Yeah, I divide by 0. So that means that's extraneous on that one. That's why we check it. Is because, one, if it doesn't balance, the left side and the right side is extraneous. But it's also extraneous when it makes me divide one of the fractions by 0. Okay, so this one, as I go to do that check step, and some of you are like, I really don't want to check it, I want to go on to the next problem. And you put both those answers down. You now miss the problem. Because 2 doesn't work. Because it makes both of them. It makes the two fractions, both of these 0 is what they do on that side. Because 2 squared is 4. 4 minus 4 is 0. Okay, so then you got 2 equals 0. No, it doesn't. Okay, so that's why we check. All right? We don't want to skip it for laziness. I got to erase that part there so I have room to work. All right, we got a few. We got 3 more. Okay, notice how they get a little bit crazy. Yes. Yeah. All right, so I have 13 over 3 times w minus 1. I'm just going to take out that 3 so I can look at it in its factored form so I can figure out the least common multiple. And 9 is 3 times 3. So as I look at it, technically 9 and then w minus 1, that would be the least common multiple of the bottoms. So 9 times w minus 1 times the first fraction. Nine times w minus 1 times the second fraction. Again, if I could go back to your younger self 2 years ago and stress the importance of showing all the work and doing all the little stuff with factoring on when is it going to come about 2 years later, I wish I could. But I can't. But you got to trust me when I say from the standpoint, if you're taking dual algebra, you're taking pre-cal, even if you're taking math reasoning next year, then you're going to take algebra in college, dual algebra or college algebra in college. You're going to have to factor. Okay, at some stage in order to get through that course. Statistics is the only course in college that you don't have to worry about factoring. So you may want to take that instead of taking an algebra course to get your math credit. Okay? If this is your kryptonite, When you go to college, take some other thing, the math course that'll get you. But don't take logic. Okay? I had friends in college back in the late 80s, early 90s, like, I'm terrible at math, so I'm going to take a logic course. They were in here actually worse over their heads with the logic course. Because very few people can help you teach logic math. It wasn't what you think about logic, All right, here we go. W minus 1's cancel. 3 goes into 9 3 times. I'm left with 3 times 13. Minus the W minus 1's cancel. I'm left with 9 times 1. The 9's cancel, and I'm left with W minus 1 times W in that spot. So 39 minus 9 equals W squared minus W. That is technically 30. And I'm going to subtract that over to be to the other side, and I get 0 equals W squared minus W minus 30. That factors into a W minus 6, W plus 5. So W is equal to 6, and W is equal to negative 5. Then I'm supposed to check. Now, I notice right off the bat, neither of them make them 0 in the bottom, so we didn't get off lucky like we did on the previous problem with the 2. So is 13 over 3 times 6 minus 3 minus 1 over 6 minus 1. Are you equal to 6 over 9? So is 13 over 18 minus 3 minus 1/5 equal to 6/9? Is 13/15 minus 1/5 equal to 6/9? Nobody has a common denominator, but the first one they have in common, multiple, is 45. So is 39 over 45 minus 9 over 45 equal to 30 over 45? You betcha. All right. So we know that one worked. Now we got to try the negative 5. 13 over 3 times negative 5 minus 3 minus 1 over negative 5 minus 1 equals negative 5 over 9. 13 over negative 15 minus 3 minus 1 over negative 6 equals negative 5/9. So that's negative 13/18 plus 1/6 equals negative 5/9. 18 is the least common denominator, so negative 13/18 plus 3/18. Are you equal to 10/18? And a negative 10/18 to be exact. Yes. So those are both my solutions. Again, checking it's tough. It takes a while. All right, last 2. Oh, sweet. There's only one denominator. So that's the least common denominator. So everybody gets multiplied by an x plus 3. All right, here we go. On the first fraction on the left, the x plus 3's cancel. I'm left with x plus 6. I'm going to go ahead and distribute the 2. 2x plus 6. The x plus 3's cancel, and I can distribute that negative sign to both parts of the top. So minus 5x minus 12. X plus 6 equals negative 3x minus 6. I'm a positive person, so I'm going to add 3x over. 4x equals negative 12 divided by 4. X equals negative 3. And then I notice, what does the negative 3 do to my bottom? Yeah. So that's an extraneous solution, which means this one has no solution. That means there's no number in our number system that will balance that problem, is what that means. Okay? Since we only had one that we found, potential, one candidate that we found, and that candidate failed because it made us divide by 0, then we say this thing has no solution. This problem has no answer. It cannot be solved to get one unique number that will balance it. Okay? And that can happen. All right. Last one. Number 12. Then I'll give you your worksheets for you to start practicing. All right. I'm going to factor out the first fraction. So 3c minus 2 over c times c minus 4. And so c over c minus 4 minus 1. All right, so I noticed that the denominator on the left, that one right there, that's my least common multiple. C times c minus 4. That's the least common multiple. So we're going to go ahead and multiply each part by that bottom. C times c minus 4 times the first fraction, 3c minus 2. C times c minus 4. Sorry for the parentheses and the c's looking the same. That is really bad. Yeah, you can use x's. C times c minus 4. Holy smokes. This is really bad. And then on the last part, nothing really cancels because it's, c times c minus 4 times 1. All right, here we go. On the left side, the denominator cancels by what I'm multiplying by, and I'm left with 3c minus 2. C minus 4 cancel, and I'm left with c times c. And then really, I'm left with negative and then c squared minus 4. So I'm going to clean that up some. 3c minus 2 equals c squared minus c squared minus 4, or plus 4, sorry. Forgot to distribute. That's why I like going to McDonald's. Remember those arches. C squareds cancel. I'm left with 3c minus 2 equals 4. Add the 2. I get 3c equals 6. Divide by 3. I get c is equal to 2. Okay, that doesn't right away make me divide by 0, so now I do have to check. Is 3 times 2 minus 2 over 2 squared minus 4 times 2. Is that equal to 2 over 2 minus 4 minus 1? And that would give me 6 minus 2 over 4 minus 8. 2 over negative 2. That would give me 4 over negative 4 equal to negative 1 minus 1. Nope. Did I make a goofy mistake?
I just have a question.
Yes.
I don't know if you made a mistake.
About the who?
I don't know if it was you who made a mistake, but I just
That's why I asked.
I don't know how you got the c squared minus 4 because
I forgot to distribute how did I get the c squared minus 4?
wouldn't it be
It should be a c. Yeah, it should be a 4c. Yeah. That's where I was wondering if I made a goofy mistake. I didn't do. I made the mistake of not tracking. Hold on a second. Yeah, that part right there. That little part right there. So you guys let me get it way down there before you said something. So like, it's okay, Mr. Stevens. We'll just sacrifice you. I'm the first one voted off the island. All right. So 3c minus 2 equals c squared. And then it is a minus c squared plus 4c. Cancels 3c minus 2 equals 4c, minus 3c, minus 3c. C is equal to negative 2. Then I got to check 3 times negative 2 minus 2 over negative 2 squared minus 4 times negative 2 equals negative 2 over negative 2 minus 4 minus 1. Hi, yep, it works. All right, so I will pass you out the homework page. You will give these to Miss Manwaring tomorrow.